Hi, families. I wanted to just spend maybe 8 or 10 minutes talking with you about something called the eight mathematical practices. Um, these are practices that define kind of behaviors that we want students to have or that we want to be developing in students in kind of grades K to 12. So I want to give you a short background on my experience with math. So I taught first grade when I first went back to teaching at the elementary level for about 9 years. And I had an experience my last year of teaching first grade. I took a class. And if you've ever had one of those kind of experiences that you feel like was kind of career changing, it was one of them. I was actually taught by an instructional coach in Evergreen at the time, who now works out here in Battleground. And what I found out when I took that class is there was a lot that I didn't know about how my kids learned mathematics. I knew a lot about how they learned to read and write because I taught first grade, but I didn't know that much about how they learn math. And I became pretty fascinated by it. So I started a journey, for lack of a better word, of a lot of professional development around math. I ended up changing grade levels. I went to fourth grade. I taught a little fifth grade, just math and science, and now I'm in third. I had a bit of time in there where I was a math intervention specialist in this district as well. So I love to teach math. And part of that, I think, is supporting families and supporting kids to love to learn math. And these math practices might serve to illuminate some of the shifts that families sense but don't quite understand. So there's 8 of them, and they describe behaviors that we want to be developing in students in grades K through 12 to really ensure um, not only an understanding of math, but really kind of, a pretty steady achievement rate in math, which isn't always the case. It is focused pretty heavily on developing reasoning skills and math communication skills. Now, when you read them, they're not very easy to understand, to be honest. They're just written in ways that I think people who wrote them understand them. Definitely third graders don't understand them. And so, what I've tried to do is take them and put them to the best ability that I can into math language. And because we talk in our class about being math ninjas, we talk about with excitement about learning math. Um, we're going to call those 8 math practices our math ninja belts. And so I'm going to describe them to you kind of in third grade language. So the white belt is simply that ability to persevere when solving problems. So I can solve math problems without giving up. And that is foundational. And it comes when kids believe that if they work hard at it, even if it's hard, they can do it. And I think it also really comes with the belief that everybody can be successful with math. Lo and behold, by third grade, a lot of kids, unfortunately, have already decided they can't do math, and which is a really sad situation for them because math is a requirement. It's a requirement to graduate from high school. And so making sure that kids believe that they can do math is kind of part of my job. And a big part of that is making sure they understand that speed's not the most important thing. Some kids think about math more quickly. And kids come to believe that they're not fast at doing it, they're not good, which I dispute heavily with them. And I try and explain to them that I'm not that fast at math. And I always get a little stressed when I'm doing math in like some teacher professional development and people around me are faster. And I have to remind myself speed is not the most important thing. So that's math belt 1 or white belt, math practice 1. So the yellow belt is I can think about numbers in many ways. This one really is about thinking about numbers and what they mean in a math problem, what units are in a math problem, and what operation that I need to use. And so it's a little broad in its structure. It also has to do with number sense. And I made a short video already about that, like knowing about quantities, how big and how small, and how different quantities are related to other quantities. So that is our yellow belt, or math practice number 2. 3 is our orange belt. And this one we've talked a lot about recently, and that is that I can explain my thinking and I can try to understand the thinking of others. And so when I explain my thinking, I can either do that verbally, or I need to be able to show in writing with words, numbers, or pictures how I thought about it. And this can be a challenge for kids that have kind of a strong innate sense of math, but where they're getting better. And as I show them ways that they can kind of show their thinking, I think they're a little relieved, like, oh, well, this isn't that hard. Part of it is also just slowing our brain down enough or being willing to take the time to think about how they thought about it. But another really important aspect of this is being able to read and think about how others solved it. And this is tricky for a third grader. A lot of them are like, well, I solved it. I don't really care. Um, so I asked my students the other day, why would we do this? And they said, well, they think we should look at other people's work to make sure they got it right, which is really the last thing I want them to think. We talked about the reason we look at other students' work is because we can learn from it. And we can see that maybe they solved it in a way that's different from us. And we might try the way that they solved it. So something really important, and it has to do with that communication piece. The blue belt is I can use the math I know to solve problems. And so this is a lot about the solving problems work. And we've had a couple of activities in the last couple of weeks about that. Reading problems carefully, being able to identify the quantities that we're going to use to solve it, thinking about, is this an addition problem? Is this a subtraction problem? Is this a multiplication or a divide problem? So kind of thinking about what kind of problem it is, and then being able to solve it. And when we solve it, go, that answer makes sense. So I can use the math I know to solve problems is the blue belt. The purple belt has to do with using math tools and being able to use them and know why you're using them. These can be objects, which unfortunately we don't have a lot of access to right now, but they might be base 10 pieces. They might be a number rack. They might be tiles, which hopefully students will be getting distributed to them soon. They're really important for multiplication. So they can be physical objects, but they can also be tools like a table. I mean, I would say even like a diagram can be considered a tool. So anything that we use to help us think. And I always think of drawings as a way, or pictures as a way to communicate how we thought, but also just a thinking tool. And it is interesting how kids will use tools and not really make sense of them or know why they're using them. They're just using them because they have been told to. So that's kind of an interesting practice, is being able to know which tool is going to help you, and how did it help you. Our brown belt has to do with precision. And so this is kind of a maturity thing, but I do my work carefully and I double check work for accuracy. So a lot of kids don't want to work that carefully. They'll just want to solve it and move on, which is, kind of an 8 or 9-year-old kind of thing. So we want to develop in them that habit of going, wait a second, did I slow down and work carefully enough? And when I got done, is there a way that I could double check my work? And so that's really primarily what the brown belt is about. The red belt, the red belt and the black belt are very similar. And I think they might shed a lot of light on some of our efforts right now in math. They're both about making generalizations or looking for patterns. Now, traditional math, kind of what I would say top-down math or very direct teaching, gives students those rules or generalizations. Like one, for example, is, and not a third grade example, but an older example, is when I multiply fractions, I just invert and multiply. That's a rule. And we probably all learned it. And what's interesting is I've had 5th grade students, as we've worked with fractions, develop that rule. Like they generalize that. They knew enough about how multiplying fractions worked to notice that the answer would be the same as if they inverted one of them and then multiplied. It's pretty interesting. So that's a big shift, is that we notice patterns and we use them to solve new problems rather than just feeding kids those rules or those patterns. So the second part of that is noticing shortcuts that can make your work more efficient. An algorithm is a good example. So using a standard algorithm for addition is a great shortcut. It's pretty efficient. What we're doing is just taking a series of single-digit problems and using them to solve a multi-digit problem. But there is a lot of learning about place value that needs to happen before we take that shortcut. But we do eventually want to use shortcuts. We want to try, as mathematicians, with making our work as efficient as possible. So those are the 8 practices. I hope they kind of define for you what we're trying to do. I think they're really important. I believe in them wholeheartedly. I see kids come to love math when they're emphasized in instruction. I see kids make more academic progress. Um, and I think kids are better prepared to go on and reach higher levels of math if they begin to develop these. So, anyway, I hope this didn't get too long, and make sure that you reach out to me if you have any questions. So, thanks for listening.